Yeah, it's very confusing. Okay, so this first problem says the trajectory of the water from fountain A is represented by the function in standard form, while the trajectory of the water from fountain B is represented by a table of values. Compare the vertex of each function. Which trajectory reaches a greater height in feet? So, fountain A has the formula, and fountain B has the table. So I'm going to start off by looking at fountain A. I am going to write my equation. So I want to figure out which one has the greater height. I want to find my vertex of these functions. So this first one, I'm going to need to use the x equals negative b over 2a to get the x value of my vertex. So what's my a, b, and c values here? Okay, so then I want to plug into the formula. So x equals negative from the formula, 2 for my b value, over 2 from the formula, times negative 1 for my a value. So on my top, what do I have? And on my bottom, negative 2 divided by negative 2 is 1. Then I want to go ahead and plug into my function. This negative is outside the parentheses. 9. So then my coordinate point is going to be 1, comma 9. So this 9 is meaning it's got a height of 9 feet. So on fountain B, what's my vertex? Do you remember how I can tell with the table of values? So if I look right here, this point is in between two of the same y values. So this one's height is what? So which fountain has a greater height, A or B? B. Okay, so on the next problem it says Mia tosses a ball to her dog. The function f of x equals negative 0.5 times negative, or x minus 2 squared plus 8 represents the ball's path. What does the vertex form of the function tell you about the situation? So I'm gonna just copy down my function right now. Okay, so this negative right here means it opens downward, which makes sense. If you're throwing a ball in the air, it should fall back down. Okay. And then from here, I can get my vertex. What's my vertex? Anyone remember how to find my vertex? Close. The 8 part's right. Mm-hmm. Yep. So the vertex form tells you the vertex of the graph of the function, which is going to be 2, 8. And the ball reaches a maximum height of, whenever it says maximum height, this is always going to be my y value of vertex. Yeah. And then how far away from where she released it? 2. If I've used my 8, the only number left is 2. Okay. So the next part of the question wants me to say what standard form tells me about the situation. So I need to rewrite this in the standard form. So I need to do what we learned last chapter with our multiplying polynomials. So instead of writing x minus 2 squared, I'm going to write x minus 2 twice. Bless you. So I can go ahead and FOIL. So this negative 0.5, I'm going to leave it alone for now. What is x times x? X times negative 2. X times negative. Negative 2 times x. And then negative 2 times negative 2. And then I close off my parentheses, and I still have that plus 8 on the outside. Okay, so now I want to combine like terms on the inside. So the x squared stays the same. What's negative 2x minus 2x? And then I still have that plus 4. Close my parentheses. I still have that 8. Now I want to go ahead and distribute that negative 0.5. So negative 0.5 times x squared is going to be negative 0.5 x squared. Negative 0.5 times negative 4, x, negative 4x. negative 0.5 times 4 minus 2. And then I still have the plus 8 at the end. Okay, so then I just want to combine my terms. So I have negative 0.5x squared. That's not changing. I still have plus 2x. And then what's negative 2 plus 8? So what's my y-intercept here? So what do you think the y-intercept is telling us if we think back to this picture? What's happening at the y-intercept? Yeah, it's we're starting this row. So the y-intercept is 0, 6, and then the ball was thrown from 6 feet